Okay, good morning. Good morning, everybody. Thank you for joining my session today. My name is Cristian Schuszter. I'll be talking about developer productivity engineering at CERN today, also known as DPE. If you like acronyms, we like acronyms a lot at CERN. CERN means the European Laboratory for Particle Physics, okay? It's not in the letters, it's a bit, we changed the name. The original one is in French. I'm not going to bother you with that. I hope you didn't come to this session just because my name sounds German. I'm not German. But who am I, right? So I work at CERN for like the past 8 years or so. I have around 11 years of experience working as a solution architect in something called a business computing group. So I'm going to be going a bit more into detail about that in a second. It might look like I work in construction. That's only because, you know, safety first at CERN. So whenever I guide people underground and so on, we need to wear helmets, right? Just in case something very heavy falls on your head, you know, liability and so on. So yeah. Now, of course, I'm not going to be talking about myself. I'm going to be talking about a few different things, right? So first, we're going to cover the challenges that we face at CERN in terms of developer productivity and what that means. Then we're going to be talking a bit about homogeneity, right? So how things can become uniform even if we're in a very diverse environment, let's say. Then we're going to be talking about Gradle and other related tools that we use inside our group in order to make our life better, and a couple of lessons that we learned along the way. So if you take one thing out of this presentation, it should be this one. So the fact that I tried to draw this little nice Venn diagram of stuff that you should think about when you talk about developer productivity engineering, right? It's quite a vast domain and it's pretty vague sometimes. But you should look at architecture, you should look at standardization, you should look at building communities, and at tooling, right? And we're going to kind of go through each of them at once to see exactly what we did regarding each of these steps. Some of them are more technical, some of them are more blah blah, right? So maybe documentation or whatever, which I know is boring for many of you, but it's something which is useful. And this is the thing that we're talking about, right? So we built the largest scientific instrument in the world. It's 27 kilometers long. It's also under vacuum. It's also at almost 0 Kelvin most of the time when the accelerator runs. And it's in beautiful countryside France and a bit of Switzerland as well, right? Next to the Lake of Geneva in Suisse romande, right? And yeah, you know, like delays are expensive. Things like that need to happen on a constant basis, more like 40 million times a second when the accelerator is running. These are the 4 main experiments of CERN: ALICE, LHCb, CMS, and ATLAS. Each of them are placed on certain points on the ring, right? So delays, outages, anything like that can cost us hundreds of thousands of francs, right? This is why we should look at these things. This is why we should probably focus on developer productivity to make sure that whenever something bad happens, we can recover from it fast, we can develop things faster, and so on, right? You probably identify yourselves with these situations, I guess. Maybe it doesn't cost you hundreds of thousands of francs or euros or whatever the moment you have an outage in production, but it's still something relevant, right? And more specifically, I'm going to be talking about work that we do in the business computing group at CERN. So this is a bit of an adjacent area to what the physics work at CERN is, right? So you have to imagine us as a huge organization, around 13,000 people on site every day and so on. And we have systems like any other company, right, which need to handle accounting, procurement, everything that needs to spend those 2 billion francs in budget that we have every year in order to buy new equipment, to maintain things. The electricity bill is quite big and so on and so forth. We use about as much electricity as the city of Geneva, right, when the thing is running. And because it's a complex organization, it also has complex systems. We don't really abide to any specific laws, right? So because of this, we end up in a situation where we need to implement a lot of custom, let's say, business logic, right? We have lots of legacy. We also have a lot of new projects. This diagram over there, it's made unreadable intentionally, but it's just a high-level overview of financial systems at CERN, right? So this is only ERPs and stuff like that, right? And we can't afford to reinvent the wheel. We have around 80 developers with PMs, POs, designers, as you would see in a normal organization, right? So it's nothing really sci-fi, right? We're still working in kind of an agile environment. We've been trying to use SAFe for the past couple of years and so on, which works kind of well for us. So yeah, and it's quite costly to be inefficient. These critical systems, even though they don't touch the accelerator itself, they're still fundamental to the research job just because it blocks people from actually doing their job. If something breaks, for example, in one of our access systems, then you can't go downstairs and actually badge in to access the accelerator, which is not great, right? Suppliers, parts can't arrive in time. Invoices, we don't pay them on time, then we have issues and so on. So that's just a small fraction of the cost of inefficiency. To add to that, there's another challenge, the fact that being an international organization, contracts are kind of short, right? So in general, we have people that stay here for 2, 3 years, maybe 5 years, right? And then they go. They leave with the knowledge most of the time as well, right? You probably identify yourselves with a situation in which some of your colleagues have joined, learned a lot about a certain thing, or maybe worked individually solely on one project, then they leave, and then there's like, you're going to be the one which is maintaining that application from now on, right? And you have no idea what's going on. This is the same with us, so we have a lot of turnover, which adds to the issue of making people productive as fast as possible the moment we onboard them, right? And to add to that, there's the cognitive overload of just being in an organization which is complex, right? So having multiple teams. This is the business capability map of our business computing group. So different teams that handle different parts of our systems. Some of them are shared, which makes things even more complicated. It's your responsibility. No, it's your responsibility, and so on, right? So it gets quite tricky to handle all of this. So looking at it just from the legacy perspective, right? Look at this. This is a presentation from Java 1 2000 about Java Servlet API, Oracle 8i, Enterprise Java Beans, and so on, right? This is how the production application looked like for ordering stuff. So if you want to order stuff from the CERN store, you fill in this form, We went paperless around 1998, right? And since then, we don't really sign on paper anymore. We sign everything digitally, and it goes through a workflow, right? So this document is from 2000. A couple of months ago, I created another one, right? It looks exactly the same on the surface, right? Underneath, of course, maybe it's Kubernetes or whatever, but your users don't care. It's more about how do you actually manage these beasts, that are still being used nowadays. And, you go from this to that. It looks similar. People don't get lost in your interface. Under the hood, it's all modern, right? And, if it's still used, it's not really legacy, right? That's kind of our motto that we work on in the group. And the problem there is that really, we want to make sure that even though there's 30 years of history behind us in terms of Java development and so on, we handle it properly, right? So this is a bit the intro, and now let's look a bit at environments and what we actually do concretely to handle developer productivity engineering, right? So the first thing is something very organizational. Let's talk about people, right? So we organize in communities of practices inside the group. Maybe you heard about this term before or not. So the idea is that you have people that are interested in a certain domain from multiple teams, right? So this is a cross-team initiative. And maybe they're interested, I don't know, in backend development or in DevOps or whatever. They all gather together and they share their experiences because maybe one team has a completely different way of working that is better than some of the other teams, right? But if you keep silos inside your organization, then you're going to end up in a situation where a team is maybe very productive, and then the other ones don't really learn from that, right? Because they don't communicate with each other, they only focus on delivering and delivering and delivering. And this is quite nice. For example, this is an interesting presentation that we had from a Swiss company that was talking to us about testing, and then they were using examples like, look, CERN is very similar to what these guys do, right? Because, I mean, it's still big systems and so on, and lots of it is embedded and all that. But it's an excellent way to break silos. It's an excellent way to re-engage people in the group to work on certain things, and you also spread knowledge a bit more evenly across the organization. So it's something that maybe you should think about doing, or maybe you should actually be interested in implementing if you don't have something like that. Some people call it guilds or whatever, in their organizations, but yeah. Another thing, which is very concrete, it's ADRs. Does anybody know what an ADR is? Yeah, 5% of the room. So this is a nice little concept. It's an architectural decision record, right? So the idea is that whenever you do something bigger at the group level, you write it down. And then you have other people in the group that actually review those things. And you go through the possible options that you have, right? So maybe we can do 1, 2, 3. Why? Well, because it stays written down there. Other people ensure that maybe we're not doing extremely insane stuff. And at the same time, it stays there as a kind of historical marker of why certain things were done in a certain way. How often does it happen that you look at code? How many of you are developers actually in this room, like actually writing code? Okay, good. So I guess it happens at some point, right, that you look at your code base and you're like, why? Why would you do it like that, right? Well, this is one of the very good reasons why you should implement ADRs as at kind of like the organizational level, if you can, right? So even though people are from completely different teams, this is like about Oracle HR, so it's like a system from Oracle for synchronizing people and so on. This is not my domain, but I can also look at that and understand why something was done. If people move from a team to another, then of course it's going to be very useful for them to be able to see this and to understand why certain decisions were done. Another very useful organizational thing that we actually were doing is tackling technical debt as a feature, right? So as you can expect, when you have a 30-year-old application that has been like kind of you're changing things while the car is running in the engine, which is not sometimes an ideal situation, right? You have to stop from time to time and look at it and be like, oh, this is unmaintainable now, right? So we need to start working on it. Of course, refactoring should be something that you implement on a day-to-day basis in your workflow, right? But there's also the problem of, well, what if we have something bigger? Then we treat it as a feature. Okay, so every quarter or so, we kind of do this exercise of doing the technical debt criticality matrix, so this kind of thing. We have a tool for it, and basically we say, okay, how bad is it in terms of security, in terms of auditing, privacy? We're not that great there, and so on, right? So you look at this map, and basically, if things get worse, then you're like, why? If things don't get worse, then you're maybe we should make it better at some point in terms of deployment, in terms of the quality of the code itself, and so on. So it's very useful, and it's a good selling point to your PMs or whatever, saying, look, if we don't do it now, we're going to pay a lot for it next quarter when we need to implement a huge feature related to that part of the code, right? So it's a good selling point to say, this is not something that your users will see tomorrow, but it's something that will make you way more productive in the future, right? Then architecturally, maybe you want to look at your code, maybe you want to look at what you're building, and think of an architecture, some way of organizing your code, which is future-proof, right? In our case, we started exploring a lot hexagonal architecture. It works pretty well for some of our services. And to enforce it, of course, because you might have new people that come in and so on, you have this nice little project, it's called ArchUnit, that allows you to test your architecture. So basically, it goes through your packages. This is Java, because we're a Java shop mostly, but you can probably find similar things in other languages that make sure that certain things don't get tightly coupled between each other. Your domain stays pure, and then, then there's all the discussion about it, there's this onion architecture and so on, right? So this is another very interesting thing that you can do and something that you should look at. Think about how your things are built. Of course, for a huge application, maybe it's not something that you can do out of the box. You're going to need to take pieces out of it, refactor it into that model, and then continue moving as the thing runs. And just so everybody's on board with what we're doing in terms of technology, we have this. What's this? A tech radar. So we have a tech radar, which basically we update from time to time saying, look, this is the technologies that I want to adopt and that we're supposed to be using everywhere in all the teams. Then we have trial, right? So things that we might want to use, but we're trying it in a POC or like a small project or whatever. Assess is like, okay, we don't know about it, so maybe let's look at it, and hold is like, don't use it. And it's interesting how things evolve, from time to time. So if you look at the tech radar from now and the tech radar from a few years ago, it looks slightly different. And you can also trace the way of how things are being built in the group. And whenever you need to add something new, you go through kind of the same process as the architectural decision record, but more like, okay, let's document the options that we have. Let's do this. Let's move towards this technology. Not everybody should bring like a new library into the project every day. If any of you are using Node.js or NPM dependencies and so on, you probably know that it's not a great thing to just bring in a random dependency from the internet into your project and say, yeah, this one is going to solve my left padding issues or whatever, right? So it's a very similar process. We have a group of architects in the group which go through every proposal of what technology we want to use. They analyze it, and then it's like, okay, pros, cons, yeah, okay, fine, let's try it out, let's go with it, and so on. So you need to be structured about it, because otherwise chaos really quickly seeps into teams, you know? If you leave them a bit like to go their own way, then suddenly you start having production services in Haskell, and you're wondering yourself, why did we go there? Especially because CERN is a very research-oriented organization, so people come with a very academic mindset sometimes, right? And they start doing some interesting work, right? Which maybe you're going to pay for it in the future. Okay, so what about the tooling, right? What about all the things that we can do in terms of, well, actual physical tools or software that can allow us to be better at developer productivity engineering, right? And developer productivity in general, right? Well, this is a low ball, but you can create your own template project generator. So imagine that you're in an organization which needs to start a new greenfield project, right? If you start a Spring Boot application, you have a million ways of doing things, right? You also have a million dependencies that you could bring in, right? So some people might want to use GraphQL, some people might want to use whatever. It's good to be opinionated, right? So there's this little tool, it's called Yeoman, which basically, well, it's this clippy thing from Office from the past, right? Which basically it's like, it looks like you want to create an application for BC, right? So for our group. And basically you say, okay, I want the Spring Boot API, and it already knows, it will ask you a few more questions, of course, like, do you want this, do you want that, do you want to integrate with Vault, do you want to have all these things in your project, depending on what you want to build. And then it's quite easy to use it, right? Because there's a small templating language that you have to define. Sure, you need to maintain maybe these dependencies, so from time to time you're going to need to bump versions and so on and so forth and make sure that the starter projects still work. But it aligns everybody at the same level of, well, work that you want to do, right? So when another team will need to start building an application, they won't start from scratch. They won't start from like a blank slate where basically they can go in any other direction, right? It's very important to keep things homogeneous as much as possible if we can. Sure, there are specific use cases where some dependencies might be very, very specific to a project. But most of the time it's just, okay, it's a REST API or whatever, sure, you're going to use this, end of story, no discussion. It's very easy. And it frees you from thinking. It's great. You don't need to think about what you're building. I mean, of course, you need to think about the features you're implementing. But you look at it and you're like, okay, fine, let's use that. You don't, it comes out of the box for you. Another thing is like, okay, we use GitLab. We mostly use open source software at CERN because, well, everything is an extra cost, right? If not. We have a big GitLab deployment. This is actually GitLab Enterprise that we're using, but still. Which allows us to build components, right? So this is more from the DevOps domain, but our DevOps teams are basically developing these different components, allowing us to say, I want to do static code analysis of my application in the pipeline. I want to build my application using a certain Java version and so on, right? So it allows you to parameterize a nice little piece of pipeline, let's call it, right? And move from something like this, which is horrible, because it's basically like, oh, if you passed in this variable and so on, then maybe tag it or whatever and so on, and then pass these arguments and then build an image and so on. It's really horrible. Imagine copy-pasting this to 80 projects, right? And having to change it, I don't know, a couple of months later because something critical in the infrastructure changes. Well, with the components, they're versioned, right? So basically the idea is that, okay, you just use this specific tag. If there's a new version that comes up, you can use the new tag, and you just pass this inputs. You see, like, you say, okay, this is the image that I want to use, this is the name of the job, and then other things you can also pass in as variables and so on. And it's awesome. Why? Because then you can build pipelines way faster, way more easily, especially if you're a developer, right? Because you don't want to concern yourself that much with all the piping, right? You just want it to work. You just want it to be deployed somewhere, right? So that's a very big step in enabling people and enabling teams to actually be able to do this. Componentize things as much as possible, right? So try to make things which are usable across all the teams. Have a team which, well, is basically like a platforms team that maintains these well, let's call them components in this situation. And then everybody can use them and profit from that. And you can go one step further and adopt a GitOps style approach. How many of you are using GitOps in production? Good, maybe you're gonna start using it more. So the whole idea here is basically that you have a nice little repository, or maybe it's the repository with your application. You put your YAML file there with the Helm charts and so on, and there's a tool. In this case, it's Argo CD. It's an open source project, which is basically built on top of Kubernetes. It looks at your repository, and it's like, oh, you changed the version of this image that I'm supposed to use. And then it automatically does everything for you, right? So it does, once you build the image, then it does all the deployment work for you and so on. Everything is defined in code, so it's infrastructure as code, basically, if you want it. And how easy it is to roll back. Well, you change the version back to the previous one if something like, if poop hits the fan, as one might say. You change the version back to the previous one, and then you wait a couple of seconds, and then the thing picks it up, it restarts the containers, and voila. You're back to a more stable version of your application, right? And you can play around with it. You can do A/B testing. You can do canary deployments and all that stuff. It's really, really powerful. It's really good for our use case. And again, it takes away all that cognitive overload of deploying an application, right? You don't need to think about it. As long as you have the infrastructure and the Kubernetes clusters to do it for you, it happens magically, let's say, for a young developer that just joined out of university. It's like, oh my God, it's magic. My feature is in production, right? I didn't have to do anything. It's a nice feeling, right? And also, it puts the entry bar low, so you can develop fast, but you can also fail fast. It's completely fine to fail all the time. Well, not all the time. I mean, don't fail all the time. But it's okay to fail from time to time and to have to deploy these things into, like to roll back stuff and so on, right? So it gives you that power. It gives you the confidence to say that I'm going to be fine, you know. And then, of course, once it's there, once it's out in the world, make sure you have logging, tracing, alerting, observability, right? So everybody's talking about observability now. Everybody and their dog is doing it, right? But it's very simple. Just log things in a central place, please. Don't put it in 10 million places, right? Because it's going to really screw up your productivity. Whenever you have an incident, then you're going to need to go, I don't know where to actually find out what's going on. And what we do actually, recently we've adopted the ECS format. So it's, well, a logging format that spits out JSON. This is only in production, of course. When you run the thing locally, you're not going to be producing JSON. But in production, you produce JSON. Why? Because all these log aggregators, parsers, and so on, they're quite crappy sometimes, and they're very finicky. So the simpler it is, the better, right? Because then, okay, you have log level, you have process PID, and so on and so forth, and you know that it's going to be the same format for every application that we have, right? Every team has around, I don't know, 10, 15 applications that they're handling, right? Multiply that by, I don't know, 12 teams and so on, you have a huge ecosystem. You don't want to be in the situation where you need to think, what's the format of that specific project's logs, right? Make sure everything is standardized in that respect, right? And then it also helps a lot to use some sort of observability tool in the front end that allows you to, well, to set up alerts, to be notified about things. So this is Sentry. I don't know if many of you know about it. It has an open source version that you can deploy on premise. It also has a cloud offering. So the whole idea here is that basically your application throws a user sync recoverable exception. You launch it as a Java agent on the side of your API or job or whatever, right? And the moment it's running, it's going to collect trace information. So whenever a call comes in, if something blows up, you know exactly where it blew up. And you get the added bonus of if multiple projects are actually all of them using Sentry, they correlate the messages between themselves, right? So you have one application which calls another application, which calls another application. It blows up in application 3, right? And on your side, you only see 500 internal server error, right? Like, oh no, where is it? What's happening, right? Well, you open Sentry and then, or open telemetry or any kind of the open, or any open source front end that you might have for your tracing capabilities. And you pinpoint exactly the place where this is happening. And this also offers you a lot of other benefits. So if you do it right, then you're going to get an overview of all the slow endpoints that you might have, bottlenecks in your application, and so on. So this is very important, especially when you have a heterogeneous environment, to make sure that you're constantly keeping an eye on it. Of course, we have our own data center, right? So we're not going to the cloud, we're not using AWS or Azure or whatever, right? That might come baked into your cloud capabilities, right? But since we're building, let's say, our infrastructure from scratch, it's a bit of a different environment, so we get to pick and choose the tooling that we want to use. But then once we pick it, then everybody ends up using it, right? Because you need to do a bit of evangelization, right? You need to kind of preach the Bible to people. Please use this service, please use Sentry because it's really nice now. But in the end, it really pays off in dividends once you actually have it running. All right. Let's get a bit more into other related tools, and mostly about Gradle, right? So how many of you are Java developers or are doing Java stuff? Good, okay, that's nice. I was afraid I'm talking to Python people. No, I'm joking. But yeah, so the idea is that we use Gradle. It's kind of unpopular, let's say, in the field right now, because, well, it doesn't have the most stable API. So if you use Gradle 3 or whatever, and then you had to migrate to 4 or 5 and all that, right? You might have shot yourself in the foot. You might have spent a sleepless night trying to upgrade your applications to the new version of Gradle. Why? Because, well, things were moving fast. Things were breaking fast as well. But we actually started using it because we were using Grails for old applications. Nowadays, most of them are sunsetted or they're being thrown into the trash as we speak. But you know, developers had an affinity for Groovy. The DSL that Gradle uses is also Groovy, so they were like, okay, Groovy everywhere, let's just do it, right? Instead of using Maven, like many people use. It's also quite pluggable, so you can write your own plugins and so on. It's good for people that use Java heavily. You can use it for other languages and so on. And the newer features, they really improve our life, actually, and we're gonna go into that in a second. So one amazing stuff that we actually use quite often is build caching. So the idea is that many people think that you need to pay to Gradle for the Develocity platform, right? So Develocity is basically the Gradle Enterprise version, which gives you a nice dashboard where you publish builds and so on, so you can see how much your builds took and so on. But actually, what you can do, you can set up your own. You can just download the build cache image. It's available on Docker. I hope, you know, after they watch the recording, they don't take it off and so on. But yeah, the idea is that you can just set up your own build cache, and it's quite a simple thing. So the idea is once you deploy it, you want to push assets, like whenever your build is happening, you want to push them to the cache, but only from the CI pipelines, right? They say don't push from multiple machines at the same time. Not every developer should be actually pushing to that cache, only the CI pipeline, right? So whenever you build master, let's say, or main, master, no master. Once you build your main branch, let's say, right? Once you push your assets to the build cache, all the other people in the group and in the team can actually benefit from those things that are built, right? So they go to their computer in the morning after the nightly build or whatever. They do a Gradle build, and magically it takes only a couple of seconds, right? So you can see that if you run a build with the scan option. Basically, it's going to ask you, are you selling your soul to Gradle and so on? Yes, and then it's going to upload all your private information up to the cloud, and will give you some statistics about how much time you saved, actually, because it downloaded stuff from the build cache. You have a local one as well, so if you build stuff locally on a branch and you move to another one, but maybe some of the things are the same, it won't rebuild them again, right? Because it's going to use it and so on. Maven, I'm told, has a similar feature nowadays. There's a Maven cache that you can use. There was an interesting talk about that in Devox last week in Belgium. But yeah, I mean, the ecosystem is evolving. It seems everybody's kind of converging on the same idea that it's a good thing to cache your stuff. Another super cool thing is that it caches test runs, right? So if you didn't change the code that might be affected by a certain test, then it's not going to run that test, right? So when you do Gradle build and you just build it without ignoring the tests and so on, it's actually not going to run those tests because it says, well, there's no chance that actually anything that touches those tests was changed, so I'm not going to run them, which is awesome for your time. Another nice thing is the fact that you can use Kotlin for the past few versions. And not just that, there's also like a nice format now that you can use to bundle your dependencies. So there are these things called dependency catalogs, which allow you to use TOML, you know, TOML, like this language that you use for dependencies, for example, in Python, I think Poetry or whatever uses it. The thing is, you have 4 sections: versions, libraries, bundles, and plugins. And basically, for each of those things, you define your version, and it gets compiled into a type-safe representation of that dependency, right? So if you have a lot of projects, if, let's say, you're building a monorepo, we have a project with a lot of jobs inside it, right? All of them are using more or less the same dependencies. But if you bump up a version, right, you might screw it up, you might put the wrong thing and so on. There might be a million strings in your thing over there. You can fix all of that by just using the type-safe dependencies, right? So the moment you change your dependency catalog, it's going to compile it into a nice little Kotlin bundle, right? Which it doesn't allow you to make mistakes, basically, right? So then, for example, look, like using Liquibase is quite simple because you say, please use all these libraries that are over there, like Liquibase, Pico CLI, Oracle 23, and bundle. So for each of those things, I want them to be used in the Liquibase runtime well, dependency, right? So it's quite powerful. It's something that, well, you can look at. I can show that to you actually really quickly. Let's see how we're doing time-wise, okay? Yeah, so I have a very, very small project here just for you guys to see. I'm not going to go very much into detail, but the whole idea is that I have a project. It's called, so one is new school, one is old school. The old school one is doing things as you were probably always doing it, right? So you define your dependencies here as you know, strings and so on, and you say, okay, this is test runtime only, test implementation, development, implementation, and so on, right? You can imagine that in a real project, I have, you know, these many of them, right? And of course, this is fine, and then of course you pin IDs and all that. But what happens if you have a million sub-projects, right? You're going monorepo, you're going full monorepo, so then you have a lot of small projects inside the root. Well, you can propagate these things through the DSL to the sub-projects, right? So you have the sub-projects block here that says, okay, I want everybody to use Java of this version. I want to apply the Java IDEA plugin and so on. And that's fine. But when you look at new school, the build file looks way more human readable now, right? Because everything is bundled into one single dependency, and you say, okay, implementation, libs, it's also like a nice little, it gives you nice little autocomplete features here. So libs.bundles.spring, right? So what's in libs.bundles.spring? Well, if you control-click it, it actually sends you to this thing. It's called libs.versions.toml. It's a nice little file that I created here in the dependency catalogs folder. And when you look at it, it's basically just what I was showing before, right? So I say, look, these are all the versions of my stuff. I can show you like a bigger project later if you're interested. But the whole idea is that you know everything that you have as versions there. If you're using something like Renovate or this bot from GitHub, which automatically updates your dependencies, it can read these files, right? So it can look at them and say, interesting. there's a new version of Spring Boot out, right? So it's going to update these versions here, try the pipeline, see that it works and so on, and then maybe you want to do it automatically, maybe you don't, maybe you want to actually have a human test it and so on, but it's quite versatile. So it simplifies life a lot, and the only thing you really need to do in your code is to use this nice little DSL dependency resolution management block here, which basically tells you where the version catalogs are loaded from, right? So libs and test libs are in these two files. They're files, but they don't necessarily need to be files, right? So we can also use remote resources. Imagine that. You push to a public, let's say, Git repo, all the versions of all the stuff that you're using in your applications, right? And then people from multiple teams, from multiple applications, they actually load those dependency catalogs, and they compile, let's say, a version of that dependency catalog for their application. When you bump up the version, well, it's a bit dangerous, right, if you think about it, but still, if you bump up the version, then everybody which is using, let's say, that latest version of the dependency catalog will pull it in, and it will build the application using the latest dependencies, right? So it's a nice little way to distribute things and to make things uniform across the whole environment, right? I'm not going to go into way more details about it because we don't have a huge amount of time. But yes, moving on. Anybody using SonarQube? Yay, okay, good, great. It's awesome to use Sonar because it prevents you from doing stupid stuff. Especially if you set it up properly and you have these quality gates when you're merging things. Don't merge trash into your production applications, right? And now, actually, I want to show you something funny. So this is our largest application here. And you can see here that, so SonarQube was added to it around 2021 or maybe a bit before. And suddenly, there's a huge spike of new code in 2023. That's not really the case, right? The code was still there. It's just that we decided, okay, we're going to analyze all of it, like whatever. Just look at all the code, and you don't need to actually make sure that your existing code is going to be, A+ in terms of maintainability, bugs, and dependencies, and so on, because you can do it retroactively. So the whole idea is that, okay, we said, let's just do it. Let's just put all the code there. It's going to say we have a lot of issues, but that's fine. Why? Because new code is always going to be abiding to the rules of what we set up now. So we said, okay, minimum 80% coverage, minimum, grade B for code smells and all that, right? Which is great because whenever new things come in, they won't be able to go into the production code. So you're not adding more trash. You see here that the bottom line there is the lines to cover, right? No, the upper line is the lines to cover. And the one that actually grows is the covered lines, right? So you can see that actually people make an effort, and slowly but surely your project will actually get to a better state just by people contributing to it, because they're forced to be more productive now, right? They're forced to actually abide to the rules, to cover everything with tests and so on. And you can see, it doesn't say here the days of technical debt that we have, but I think it was something like around 1,000 man-days of technical debt, right? It's not something that we're going to tackle tomorrow. It's not something that we're going to put a task in Jira to say, okay, 1,000 days, guys, let's do it, right? We're going to refactor this. It's going to be pure A everywhere, right? No, this is not reality. This is not most real projects, right? We do it as we go, and then we'll see where it takes us, right? And by enforcing things sooner than later, you get better quality implicitly, right? Another very important thing is maybe you need to find out where things are. And maybe you have a huge tree of projects, right? Lots of subgroups, lots of all that. Well, since we're using GitLab, they are working on a better search system, but maybe if you're using GitLab, the search is not that great, right? It's a bit crappy, right? Especially when you search for something very specific, it's going to take a long time to find it. Maybe you want to search on a certain branch or a certain commit hash or God knows what. Well, we got over that issue by using SourceGraph. So SourceGraph is a very nice project. This one is not open source. There's another thing, it's called SourceBot, which you can use to, well, to do more or less the same things, but this is quite nice. It indexes everything. You can control click on stuff. It takes you to the dependency and so on in your search, right? And you can use very powerful search filters to search for a certain language. Maybe you want to search only for your YAML and so on. I mean, I imagine that in many places, your deployment things, your YAML, your Kubernetes and all that, is separate from the actual code, right? So when you touch something, maybe you want to see what are the implications of that change, right? And if it touches many underlying repositories, or if you have database packages or whatever that you actually push to Git, it's going to be way better if people can find them easily, right? And before we didn't have that issue, we had our own instance of Bitbucket, but we're kind of forced to move to the cloud. We didn't want to do that, so we're putting everything in GitLab now, and we're using SourceGraph on top of our repositories, and it's quite nice. It's something interesting to try if you want to look at it. Secrets. How many times do people put passwords in their code, right? That's a big issue as well. And it's also a huge mental issue for people because, well, not mental issue, in the sense that, you know, when you put a password in the code, or you put a variable that's going to be replaced by a password, that really complicates deployment and all that. You need to have a file somewhere on your system which contains all the passwords to the dev environments and all that, right? It's quite horrible to maintain and to make sure that it works. So we use Vault from HashiCorp. It's quite nice because then you can say, I want all the things from travel sync to be put into this prefix over here, and then you can use them as simple Spring Boot variables. In case of Spring Boot, you can use it in Quarkus and other things as well. And if you need to change the password, awesome. You just change the password, you restart your service, and voila, it's done. Because it's going to pick up the new password from the remote Vault, right? And you should definitely think about doing that for many reasons, which are security related, but also ergonomics related as well. If you want to run the test environment locally, you just load the test secrets, and nobody from your team actually even knows the password of a certain database, right? Because it's going to be done behind the scenes for you. All right, so what did we learn? Well, we learned that everybody is different in the sense that you build your own 4 pillars of developer productivity engineering, right? We made our choices by playing around with the different options, by trying it out, by mixing them together. And this whole view, this whole collection of pillars comes together into something which we really like, which makes us happy, which makes us more productive as well. Build times are faster, things are homogeneous across the group and so on in most cases. And yeah, that's great. So the big question here is what makes your developers more productive, right? Something to take away with you is to think about this and maybe try to influence something in your organization. What's that thing which is super annoying, but everybody does it a million times a week? And it's, if we automate it, suddenly you're going to gain so much time, right? Put technical debt on your roadmap. Maybe there are things that I missed, of course, but we're constantly getting better, which is the big thing that you should look at. And where to next, right? Maybe you want to build internal developer platforms. There's a nice little talk from Martin van der Per and Grace Jansen about building your own internal developer platforms. We're not there yet. We didn't go that far, but basically it's a nice little evolution of what I was just talking to you about. And then maybe you want to integrate AI tooling. Well, it works, but not at the scale of our projects. So we use it for smaller projects and so on, Juni and agentic development and so on. Another thing that we were experimenting with, shameless plug, it's me as well, so is that we try to use RAG tooling inside the group to build a system which uses all the Confluence information that we have for newcomers, right? So newcomers could just type, okay, I'm interested in this and that and that and that, and then it would bring you the most useful information with references to our Confluence instance, right? So that's something you might want to look into. It worked really nice for us, but hallucination and answers which are not really the reality kind of killed it for us. So we didn't end up really using it in production. So that's it. You can take a photo of that if you want the code. I mean, it wasn't anything special, but in any case, if you want to connect with me, you have here these credentials here. And yeah, I put a nice little slide here. So thank you very much. I need to run off to the airport, but for any questions.